Hello, hello, it is Mrs. Edwards, and we are back. It is time to do math, and I love it. Today we're going to be solving some more exponential equations, equations where the variable is in the exponent. In our lesson yesterday, we solved these equations with a shortcut where we could force the base numbers to be the same, then use the one-to-one property and set the exponents equal. Well, it turns out in general, every single time you see a variable exponent, the first thought that you should have is logarithms. One of the main purposes of logarithms is to solve equations with variable exponents. We're going to tackle some problems using 3 different strategies today that I've outlined here for you, but I'm actually just going to talk you through each of these strategies as we get to problems that we work through. Keep in mind, please, that when you are solving equations with variable exponents, there are a million ways to solve the problem. Tons of shortcuts available to you. I am going to try not to follow too many of those shortcuts. And the reason that I'm not going to go down that path very often in this set of notes is because the analogy I guess I'll use is if I wanted to explain to you how to get to my house and you're like, no, I know the directions, I know the way. And I say, no, but there's this great shortcut. You know, you go down this dirt road and there's a big tree, a blue box, take a left there. And then all of a sudden you try out that shortcut and you get very lost and you never actually get to my house. So these shortcuts are fantastic, and if you see a shortcut and want to go down that path, absolutely go for it. But my focus is going to be getting you to your destination, which is finding x. Notice in this problem, the variable is trapped up there in the exponent spot. We can't simply undo the order of operations to get x by itself, which is why we need logarithms. So if we use a logarithm, that is going to allow us to remove that variable from that exponent spot. Strategy-wise, one of the things that I'm noticing is we have one power all by itself. A power, of course, is like 2 to the third. It has a base and it has an exponent. So we have 3 to the x all by itself. So the next thing I'm going to do is what I call log and lasso. What you do to one side, you do to the other. So I'm going to log both sides. Then using that log property, we can move the exponent to the front. Okay, I'm going to move that x to the front. That's what I call lasso. All right, so I'm lassoing that exponent to the front, and that logarithm just helped us remove the variable from the exponent and then turn this into multiplication. Now we can just undo the order of operations. I know that log of 3 looks kind of ugly, but it's just a number. It's around 0.48-ish. And log of 128 is about 2.1-ish. Okay, they're just numbers. So if those are just numbers, to get rid of x multiplied by a number, we're going to divide by that number. So I'm going to divide both sides by the log of 3. Then x is going to be all by itself. Now I'm going to make just a quick comment about using your calculator. Some of you will be tempted to find the answer to the numerator, log of 128, and find the answer to the denominator, log of 3, and then divide, and that's what you're going to get. Now that's a pretty good answer, okay, but we can do a little bit better. It depends on how accurate you want your answer to be. In math, remember, especially your science classes, we don't really want to reuse a rounded number unless we have to, because every time we use a rounded number, then we get an error in our answer, and we reuse it again, we have an even larger error. So you would be better off to enter that right there into your calculator. Anytime you have a fraction, just a calculator tidbit, if you're worried, put a set of parentheses around the numerator, hit divide, put a set of parentheses around the denominator, and then hit enter. If you do that, you're going to end up with this answer. If you compare the answer to the one we just got, 0.441166, versus 2. This answer here in the yellow box is more accurate, and you can see that the answer above it already has a rounding error out there 4 places out. That's not very far out for a final answer. So in any case, that's just a quick calculator tidbit. But let's keep going. Here we have e to the 5x equals 6. That exponent has a variable in it, so we want to immediately think logarithms. The next thing we see is that we have 1 power by itself. We're still working on strategy 1. If we see 1 power by itself, we're going to log and lasso. So I am going to log both sides. This time I went with natural log. It doesn't matter if you use log or the natural log, but I would highly recommend anytime your bases are base e to use natural log, which I'll show you why here in just a minute. But you might jot that down into your notes. If the base is e, use natural log when you log both sides. You will get the same answer if you log both sides, but there will be a shortcut. Without going down too many rabbit trails, there will be a shortcut that comes about. All right, so I natural log both sides. I'm going to go ahead and follow process like I don't notice a shortcut. I'm going to move the exponent to the front. Now that we have that exponent out front, we can undo the order of operations. Because of all the logarithms, sometimes undoing the order of operations looks challenging. So I want to emphasize what's a number and what is the variable. The natural log of e is just a number. The number 5, number. Okay, variable x. So we have 5 times x times the natural log of e. If we want to get x by itself, we want to get rid of multiply by 5, and we also want to get rid of multiply by the natural log of e. Since they are the same step on PEMDAS, we can get rid of them at the same time. So I'm going to divide both sides by both 5 and the natural log of e. When I do that, x is by itself, and then the natural log of 6 divided by 5 natural log of e is approximately 0.3583519. Now, some of you might be screaming, what? Come on, natural log of e equals 1, because you know your properties. Well, that's great. 1 times 5 is 5, and when we take natural log of 6 divided by 5, we'll get the same answer. All right, so there are so very many ways to solve the problem, so I am going to introduce just one shortcut because it's such a big shortcut. As I said, if you see base e, it's a good idea to use natural log rather than log. So if I natural log both sides because I see that base e, notice a property. The natural log has a base e, right, that is invisible. We don't see the base, but the bases match. And so that log property, when the bases match, all of that goes away, and the only thing on the left-hand side then would be 5x. Now I'll just divide both sides by 5. and I end up with the exact same answer. Okay, so a nice shortcut is if you see a base e, use natural log because that property makes a lot of stuff go away. Here we have another one, and we're still using strategy A. We want 1 power by itself. We do not have 1 power right now. We have -3 of these powers, right? E, the base is e, the exponent is 4x. That is 1 power. So we need to get that 1 power by itself before we log and lasso. To get e to the 4x by itself, I'm going to divide both sides by -3. And next, since I have my power by itself, I'm going to log and lasso. Using my own advice, I see a base e, so I'm going to go ahead and natural log both sides. But right now, I'm going to stop and I'm not even going to move the 4x to the front, which I could if I didn't notice something. Okay, but see how I'm taking the log of a negative number? We know that you cannot take the log of a negative number or 0. So right away, I know this is no solution. If you just continued following process and you didn't notice that right away, you would have moved 4x to the front, and then you would have divided both sides by 4 natural log of e. And when you picked up your calculator and did natural log of -20/3 divided by 4 natural log of e, it would have said error. And that's because we can't take the log of a negative number. Here we've got another problem, and I want you to just think for just a moment after these ones we've done so far. What would you do first? Okay, here's my original. You're looking for 1 power. A power has a base and an exponent. So the base and the exponent is 2 to the power of t plus 5. You want to get that 1 power alone, then you log and lasso. To get that power alone, I'm going to subtract 4 and then divide by 6. So if I subtract 4, I have that. Then I'm going to divide by 6, and I now have that power by itself. Once you have the power alone, I'm going to log both sides. What I do to one side, I do to the other. So taking the log of both sides, I'm going to now lasso the exponent to the front. Danger. Please make sure you don't just accidentally write t plus 5 in the front. When you're up there in the exponent is inside of grouping symbols, even though we don't see those parentheses. Okay, so moving that t plus 5 to the front, make sure you do that inside of parentheses. As soon as you have removed the variable exponent and you put it out front, you're ready to undo the order of operations. I know, again, logarithms look kind of ugly, but like log of 2 is just the number about 0.3. If you had t plus 5 times 0.3, what would you do? You see a number in front of parentheses, you have a compulsion hopefully to distribute. So I'm going to distribute log of 2 through the parentheses. It's like multiplying through by about 0.3. So I'm going to have t times log of 2 plus 5 times the log of 2. I've run out of room, so I'm just going to move the exact same thing right there. Next, once we've distributed, remember, like variables on one side, numbers on the other. So let's make sure you know which is which, just emphasizing. Log of 2 is just a number, okay, around 0.3. Here we have 5 times around 0.3, it's just another number, equals log of 7/6, which is just a number. So if we want to move all the numbers to the same side, I want to subtract 5 log of 2 from both sides. So that way my t's are on one side and my numbers are on the other. Okay, next, to continue getting t by itself, log of 2, again, that's around 0.3. If you have 0.3 times t, to get rid of 0.3, you would just divide both sides by 0.3. So in this case, I'm going to divide both sides by the log of 2. And if you're going to put this into your calculator in one step, you want to make sure you put a set of parentheses around the numerator and a set of parentheses around the denominator. T is by itself, and we get negative 4.776076, and then you can round up that to whatever place value you want to. Thinking about your strategies again. The only strategy we've taken a look at so far is having one power by itself on one side, and then you log and lasso. Here we have multiple powers, right? On the left-hand side, we have a base with an exponent. On the right-hand side, a base with an exponent. So if we have multiple powers in the problem, the next thing we can try is one power on one side and one power on the other. Okay, so now that we've got one power equal to one power, the next step is going to be the same as our first strategy because we want to remove the variable from that exponent spot. So we're going to log and lasso. Because I see a base e, remember I want to take my own advice, that when you see a base e, instead of just log both sides, let's choose natural log of both sides because it's going to make the problem a little bit easier. All right, so natural logging both sides. Now technically I could lasso, but focusing there on the left, the reason why I like the natural log of e is the base that we don't see is base e. So this e matches with this e, and all of that goes away. And on the left-hand side, all we have left is 3x. Okay, then on the right-hand side, I am going to lasso the x plus 5 to the front. Now, danger, danger, right? What are we going to do when we move that x plus 5 to the front? We're going to put it inside of grouping symbols. Now that you have removed the variables from the exponent, we are ready to just undo the order of operations, just solve with basic algebra. These logarithms sometimes make it seem like it is tougher, but remember, ln of 2 is just a number like around 0.3. So I started by distributing the ln of 2, and then I want to get x's on one side, numbers on the other. So I'm going to color code this really quick. Notice that the first term there, that has an x in it, so that term is an x. Right there, that one has an x in it, and then this one does not. So we want x's on one side, everything else on the other. So I'm going to subtract x ln 2 from both sides because that's going to put all the x's on the same side. So there I have it after I've subtracted x ln 2. I know I can't combine, but I have moved all the x's to one side, everything else on the other. Because I can't combine, all I need to do is factor out the x because it's in common. Okay, so there I'm taking out the x out of those two terms. Now 3 minus ln of 2 is like 3 minus 0.3-ish. Okay, it's just a number sitting there. So to get rid of multiply by 3 minus ln 2, I'm going to divide both sides by 3 minus ln 2. And when I pick up my calculator, I'm going to make sure that I put a set of parentheses around the numerator and denominator when I enter it. And so x is around 1.5023654. Here's another one with that same strategy, but my bases this time are not e. So I'm going to go ahead and now that I've got one power on one side, one power on the other, I'm going to log both sides. Now you could log both sides and you're going to get the same answer. For no particular reason, I chose natural log. They're interchangeable as long as what you do to one side you do to the other. You can choose log or natural log. So I went with natural log, ready to lasso. So moving that 7x plus 1 to the front and the x minus 4 to the front. Okay, next, now that I've got the variable exponent out of the exponent spot, I'm ready to just do the algebra. So ln of 5 is a number outside of parentheses. ln 2 is a number outside of parentheses. So hopefully your compulsion is distribute that through. So I'm going to distribute ln of 5 and ln of 2. Okay, so ln 5 times 7x is 7 times x times ln 5. ln 5 times 1 is ln 5. ln 2 times x is x times ln 2. Danger, danger, don't write ln 2x. That does not mean the same thing, because then you'd be taking the natural log of the answer to 2x, and we want x multiplied by the natural log of 2, okay, and then minus 4 ln 2. Now that we've distributed, we want terms with x on one side and terms without x on the other side. Here I'm just color coding this. Notice this term has an x in it, this one does not. This has an x in it, this one does not. So I'm going to move terms with x to the left and terms without x to the right. I'm going to leave these ones. This one had an x and it's already on the left. Minus 4 ln 2 is already on the right. So I'm going to move x ln 2 over here by subtracting x ln 2 from both sides. And I'm going to move ln 5 to the other side by subtracting ln 5. All right, so all I did there was add and subtract to move terms with x on one side, terms without x on the other. I cannot combine what's on the left, but since I have all the x's on the same side, I can factor out that x. And then 7 multiplied by the natural log of 5 minus the natural log of 2, that's just a number. So a number times x, divide by that number. X is going to be all by itself. Make sure when you enter that into your calculator, you put a set of parentheses around the numerator and denominator before you divide. Here we have one other one that is maybe particularly ugly. And in my class, this kind of problem, I'm just going to tell you, it's the type of problem that could be a bonus question, but I wouldn't put it as a standard test question. But let's go ahead and run through it. You're stuck. You're like, oh my gosh, I can't use my two main strategies. I have multiple powers, e to the x and e to the negative x. And I can't really get one power on one side, one power on the other. So now what? Well, let's hope that you can maybe start off by letting those knee-jerk reactions from algebra just kind of play out until we see something that we can work with. Okay, some of those knee-jerk reactions should be, I see a fraction. First thing I'm going to do is multiply both sides by the denominator. Okay, so if I multiply both sides by 2, I'm going to end up with that. Okay, another knee-jerk reaction should be, ooh, I see a negative exponent. I don't like negative exponents. Let's get rid of it. So e to the negative x is the same thing as 1 over e to the x. Once again, knee-jerk reaction. I see fractions. I need to get rid of them. You want to multiply both sides by that e to the x that's sitting in the denominator. Okay, we don't want those denominators, so I'm going to multiply both sides by e to the x. Distributing e to the x through, e to the x multiplied by e to the x. Like bases, you add exponents. Okay, so x plus x is 2x. E to the x times 1 over e to the x. The e to the x's cancel, and I get just minus 1. Okay, now still kind of stuck, right? Well, a lot of equations, we always move things to one side equal to 0. Let's give that a try. And we're still maybe a little stuck. Okay, this is where we get to the strategy. We see multiple powers in the equation. Right, I see e to the 2x and I see e to the x. We have several different powers. We want to replace them with b, is what I called it. It could be any variable you want. Let me get the e to the x's to stand out. Power to a power, multiply. Right, that takes me back to 2x. But see how I've made those e to the x's stand out? Even though the original had multiple powers in it, if we can get those powers to be the same, then we can make a substitution. I'm going to let the e to the x be replaced with b. You could use any variable you wanted. I use b for base. All right, so I'm going to replace all of those with b, and now all of a sudden this equation looks pretty doable. We're going to use the quadratic equation to solve and simplify. 104 is 2 times 2 times 26, so I pulled out a 2, and then I could factor a 2 out of the numerator, making that 5 plus or minus root 26. The 2 would cancel with that 2, giving me 5 plus or minus root 26. And we solved, but did we solve for what we were trying to find? We found b, but the original equation had x, so we're solving for x. So the next thing we want to do is take the answer we got for b and put it back into what we let b equal. So I'm going to put in there 5 plus root 26 in for b, and then we're back to strategy 1. Strategy 1, we have an equation, and the equation has a variable exponent. We have one power by itself, so we should log and lasso. But because the base is e, I might as well natural log both sides. So I'm going to ln both sides, which is especially convenient because that base e matches that e, so x is all by itself, and there's my answer. We had 2 answers to b, so I'm just going to repeat. Here's my e to the x equals b, the b replacing it with 5 minus root 26 this time. And then to get x by itself, I'm going to natural log both sides, and we have our second solution. Quick strategy summary. You want to have one power by itself or one power equal to one power. Once you have that, then you're going to log both sides, then move the exponents to the front, and then continue solving algebraically. There's that extra hard one as that last example. If your original has multiple powers in the problem, then you're going to have to look to attempt to get all the powers to be the same, and then you can do a substitution with b.